This is a cross-section of a copper-plated microvia in two metal layer flecks. The additional copper to plate the hole is about 10 microns thick, and that's on top of the base copper, which is 12 microns thick. The core of this particular dielectric is the polyimide film core is 25 microns thick. So we initially drill a 45 micron hole, and by the time it's plated, it reduces that diameter at about 25 micron. So you have to allow for the plating thickness when you're calculating hole drilling or finished hole size. There are several options for via hole formation. Mechanical drilling is widely used, but they can also use mechanical punch or die press punch. There's some chemical and plasma ablation techniques that are being used for some applications, but those are not widely used in the industry, rather specialized. What is widely used is laser ablation using CO2, YAG, and excimer laser systems. When planning drilled hole size, you have to consider the land diameter. The land diameter and hole size will determine the annular ring. We need to prepare an annular ring that will prevent hole breakout, and because not all the holes are going to be perfectly aligned with the center. This particular chart covers hole sizes from 20 thousandths all the way down to 6 thousandths. These are mechanically drilled holes. There are several HDI sequential build-up fabrication variations you could consider for your rigid flex circuit. The IPC Type 1 is a multi-layer core with one build-up circuit layer on both sides with blind copper-plated microvias and copper-plated through-hole vias. The IPC Type 2 is a multi-layer core with one build-up circuit layer on both sides with blind copper-plated microvias and buried copper-plated through-hole vias within the multi-layer core. And they describe it IPC Type 3 is a multi-layer core with two build-up circuit layers on both sides with blind copper-plated microvias and copper-plated through-hole vias, as well as buried through-hole vias within the multi-layer core.